Okay, so let's talk about the ICE method using the same examples from before. The ICE method chart kind of looks like this. You're going to divide up your reactants and your products, and then you're just going to put ICE. Now, I stands for initial, what you're starting with, and then C is the change in concentration. And for these type of problems, you're going to find that by the coefficient, and you multiply it by X. And in this case, X is going to equal to the limiting reagent, okay? And then E is equilibrium. So what happens, or how much of these do I have after, so after you gain equilibrium, in other words, after the reaction had occurred, okay? So initially, what am I starting with? Initially, I am starting with 18 grams of glucose and 32 grams of oxygen. And I want to know this. So I just kind of write what I know here. And initially, I want to convert everything in terms of moles. Okay, so again, because it's just easier for me to calculate everything if it's in moles. So let's go ahead and do that for glucose and also for oxygen. For the sake of time, I'm going to kind of skip ahead because we've already done finding number of moles for each in the other ones. If you don't recall how to find like number of moles for these, then go back to the last video and watch it, okay? So we found that glucose is 0.1 moles, and we found that oxygen was 1 mole, right? Because this was 32 over 32. And we come over here, and I'm asking you, what I'm asking you is that initially, before the reaction begins, how much of this and how much of that am I going to have? And the answer is none. Like, I haven't started my reaction yet, right? I only have this much and this much of these. They haven't gone through the reaction yet. So I'm going to say 0 amount and 0 amount of each one, okay? Then the next one is a change in concentration, the coefficient times by X. So the coefficient for this one is 1, so 1 times X. Coefficient for this one is 6, so 6 times X. But these coefficients are actually going to have a negative sign because they're going to be the ones to be consumed in the process of the reaction. But these guys, the products, are going to gain then from these two, right? So they're going to be positive. So positive 6, and then positive 6, and multiply that by X. Okay, again, I don't know X yet. X is a limiting reagent, the number of moles for limiting reagent, okay? So let's go ahead and find that. So I'm saying to you that I have 0.1 mole of glucose to begin with, and in my reaction, I only need one of those, okay? So truthfully, in this reaction, how many moles of glucose do I have? Well, here's me finding X, okay? So 0.1 mole divided by just 1 coefficient, then I'm going to get, well, I'm only going to get 0.1, right? And then I'm going to say, all right, so if I have a 32, or if I have 1 mole of oxygen, and in this specific reaction, I have 6 of those, truthfully, like how many of one of these, one of just the oxygens, do I have? How many moles do I have? So I'm going to say, well, X is equal to 1 mole divided by 6, which gives me 0.166 something, okay? Then now I compare, which is smaller, 0.166 or 0.1? I see that this is smaller. So this must be my limiting reagent. So I can say with confidence, okay, this is my limiting reagent. And so X is equal to then 0.1. Okay, so X is not 0.166, it is X is equal to 0.1. So I am going to put that in here. So I'm going to say, all right, so this is -1 times by 0.1. The change in concentration then is just -0.1. Okay? For this one, so I'm going to circle that so I don't forget it. And then for this one is -6 times by 0.1, because that's the limiting reagent that we found. Then it would equal to -0.6, right? Then we do the same thing for these guys over here. So I'm going to say 6 times 0.1. That was a limiting reagent we found. That was the X. We said X is equal to 0.1. Then we say that is just 0.6. And this one the same, 6 times 0.1 is equal to 0.6. Okay? Then we move down. The equilibrium. So after the reaction, what happens? Well, you find this by adding the first two columns. So you're going to go ahead and add this one plus this one. So this one is just I plus C. And it's going to give you the equilibrium. So like what happens or how much of it do you have after the reaction? So let's see. So initially I had 0.1 mole, right? And then the change was negative 0.1 mole. Therefore, I have 0. And I ask myself, does it make sense that after the reaction I would have 0 moles of glucose remaining? That absolutely makes sense because we said that was a limiting agent. It's going to be completely consumed, right? So I have none of that left over in the end. Then I come over here and then I say, all right, so I plus C, so this one plus this one. Then I have 1 mole plus negative 0.6, that's what I found here. Then that would give me 0.4 moles. What I'm saying to you is that even the reaction is complete, I would still have 0.4 moles of oxygen left over. And that makes sense because this wasn't the limiting reagent, so I would have some left over. And I come over here and I'm going to say, all right, so how much of carbon did I end up creating? I ended up creating 0.6 moles of carbon dioxide. And then I ended up creating 0.6 moles of water. But the question didn't ask me how many moles of water am I going to have. It actually asked me in terms of grams. So I just have one more additional step, which is 0.6 mole of water is equal to how many grams? And I say 1 mole of water is equal to 18.0 grams of water. Then it is going to give me my answer, which is 10.8. There you go. There's the ICE method. I'll give you another example in the next one.